mu. This is mu,
What?
right? And then this is
Yeah.
okay.
What N stands for?
Oh no, no,
Hmm?
no. I just wanted to distinguish the letters or like the
N
symbols.
is small n. Nu is like this one.
Is it like a V sign, kind of?
Yeah, V,
Okay.
but the one side is little bit more curved.
Oh, okay, okay, okay. That's mu?
Yeah,
Okay, mu. Okay. Mu is frequency or oh yeah, frequency. Okay, yeah, yeah,
frequency,
frequency.
yes.
And what's the Planck's constant?
Planck's constant is h.
Like, is there a certain like is it like a certain number?
Like the value.
Yeah.
Yeah, so you can write down the value also here. That h value is 6.626 multiplied by 10 raised to power minus 34. And this is in meter square kilogram per second. Okay. And
Mm-hmm.
we calculate this frequency always in centimeter inverse.
Mm-hmm.
Hmm. Okay.
Yeah, let me just copy this down.
Okay.
Mhm. Also, I don't know if you received like the resources I sent, like the textbook and then the YouTube
Yes,
videos.
yes.
Okay.
Uh, I get the textbook, I think.
Oh, okay, because I sent the link to Sarah to the YouTube channel. My professor has a YouTube channel and he posts all his videos, lectures there.
Okay. I'll check
Yeah.
them, okay? After this
Okay.
class. Because IR is a little bit easier part. Okay. IR as compared
Okay.
to NMR, IR is way easier. Because in IR you only needs to after this part I'll write down some sort of the values, okay, like the values of stretching frequency. So you only needs to learn that values. That is the all about IR. By the values you can identify the graphs. Because I think in your exams they will just give you a graph and ask you that what sort of organic compound it is and which is functional group present in it is.
Yeah, yeah, yeah. That's what
Yeah.
it like when I
Mhm.
attended the class, that's kind of how like or what you were describing, that's kind of how like he ran
Mhm.
the class. Like it was you had to answer questions and you have to say like identify the functional group based on the graph and the fingerprint region and all that stuff. So
Yes, yes,
there's a lot of practice and a lot of
yes,
graphs, like
yes,
physical graphs.
yes.
But as far as like my own experience with his lecture, I honestly did not really find it helpful myself. So I really just want to make sure I can understand this chapter, like be clear with this chapter so that I don't have to worry about it. Because I can't seem to really understand his video to be honest with you.
Mhm.
And the textbook is super long, but I think
Yes,
it's worth
yes, yes.
me reading it.
Textbook, yes, yes. Textbook contain a lot of theoretical part which you doesn't need it for now. You only needs to understand the
Hmm.
graph part. Okay.
Okay, yeah, because I've like tried to read it, like sit down and read it a few times, but I just can't get myself to read the whole thing. It's like 50 pages of just one chapter.
Mhm. Yes.
So I like just want to be able to filter like what the main
Main
important points are.
main
Yeah.
part. Yeah. Yes. 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 Okay, so we'll start with that energy level of vibrational waves. Okay, so this is the formula, okay, to calculate. Do you know now? Like
Wait, what? Sorry, in the beginning, what did you write next to vibrational? What is that?
that's part. That part is like what is IR stand for? IR stand for infrared, and then in case of IR, we go with the vibrational energy part. Now see, in an atom there is a lot of energy levels. Okay,
Mm-hmm.
let's suppose do you know the quantum numbers and anything like
Mm-hmm.
that?
Yeah.
Yeah, okay. So on the basis of like different shells and subshells.
Mm-hmm.
Suppose there is a lot of energy levels in an atom. Okay, so let's suppose firstly the lowest energy radiations is microwave. Okay, so whenever we proceed with microwave radiation, or we are applying microwave radiation to any group, so in that case only rotational will take place. Rotational means means the bonds started to rotating. Okay, when we give
Mm-hmm.
microwave region. Okay, then after microwave, after a higher region, when we are applying a vibrational, or sorry, IR. Okay, so when we are applying IR, so in that case the molecules are starting to vibrate. Okay, so this energy
Mm-hmm.
is known as vibrational energy level. Okay, after some time, if we are applying, let's suppose UV or mass, so in that case, this needed a lot of energy. So in that case, the bond will be breaks, or the electron shifts from lower to higher energy level. And if I am applying X-rays, so in that case, we are getting a lot more broad spectra. Okay, so on the basis of a type of radiation which we are applying to any organic compound, on the basis of that the organic compound react. Okay, so whenever we are applying IR to any organic compound, the bonds will start to vibrate. Okay, so see, atom can be vibrated in this side or like this. Okay, around the bonds. So that's vibrational energy levels. Do you understand?
Yeah, I I think my
No.
main question was like, what? Sorry, can you go down?
Mm.
I can't. Sorry, can you go down to like the most recent part?
Most
No, no,
recent
no, no,
part
no,
of
no.
which
Recent.
one?
What is this? Quantum number. That's what I wanted to ask. Like, what does that mean?
Oh, okay.
But it's okay. I mean, you did talk about it, so
Okay. Okay.
it's like basically the frequency depends on the level of vibration, or like the wavelength, basically.
Vibrational quantum number.
Or like the quantum number has to do with the type of wavelength or type of wave, right? Type of wave frequency, like the higher frequency it is, the like more it's
Yes,
gonna.
yes. Like, yes. So n can be a vibrational quantum number. So it can be like, you can also assume n as the shells
Yeah.
or energy levels. Okay. So n is equals to 0, n is equals to 1, n is equals to 2, and that's so on. Okay, like this. And let's suppose now I needs to calculate energy for each vibrational each levels. Okay, let's suppose these are the levels. Now I needs to calculate energy. So how I'll calculate energy for each energy levels? By this formula. E is
Mm-hmm.
equals to n plus half h2. So in case of n is equals to 0, E is equals to 1 by 2 h2. Then if n is equals to 1, then in this case E is equals to 3 by 2 h nu. And E is equals to 5 by 2 h nu. Any doubt up to now, like how I'll calculate these values? Hmm?
No, no, no. Sorry, I'm still writing them down. Just give me 1 second. I'll ask you if I have a question. I'm just writing it down. Mm, okay, you're just applying the formula to different quantum numbers, right?
Mhm. Yeah.
And then based on whatever quantum number it is, it'll or like and also the type of frequency, right? Or sorry, the type of wave.
Type of energy needed,
Oh,
radiation.
energy.
And
Okay.
yeah, okay.
But that
So,
energy comes from
mhm,
the wave.
yeah,
Sorry, that
yeah,
energy comes from the wave though.
yes, yes,
The wave produces the energy. It's like proportional. So then that energy is allowing the molecule to vibrate. Obviously,
yes,
I has the energy
yes,
allows it to vibrate, but ultimately
yeah,
comes from the wave.
yeah.
Like whatever type of wave it is, like microwave or whatever.
But in this case, we are using IR.
Yeah, I like in this case IR, yeah.
Yeah, in this whole chapter, we are using IR. Okay, so there is one more thing which which examiner generally asks that in the zeroth or in the ground state of vibrational quantum number, is the value of energy will be zero or not? Because in majorly cases, as whenever we are discussing, do you know about hydrogen spectrum and all of that?
Mm-hmm.
Anything? Okay, so whenever we are discussing anything related to energy level, so we talk about that ground state. Ground state means n is equals to zero. Always at
Hmm.
ground state, energy is also zero.
Yeah.
Okay, but in this case, only in this case, at ground state, energy is not zero. Energy is equals to 1 by 2 H2. Okay, so this is very important that in this case, what is the ground state energy? So that is 1 by 2 H2. Okay. Then one more terms which we are using here, that is 0 point energy. Okay. You needs to know that part.
Wait, sorry. Give me 1 second. I'm just gonna plug in my charger.
Okay.
'Cause I don't want to miss what you're saying. So, 1 second. Okay. Oh, that's not. What in the world? Hey. Um, sorry. I don't know why my charger's not working. What? Wait, mommy, where's this charger that I plugged in not working? Great. Um, my charger seems to not be working. I might have to switch to my tablet or something in a bit.
Okay.
Um, okay. Sorry, continue. Hi, sorry. I couldn't find my computer charger, but I was able to find it. So, um, yeah. Okay. You can continue.
Okay. What is 0 point energy? So see, whenever the energy on the ground state we are going to calculate,
Mm-hmm.
that energy is known as 0 point energy. So always the value of 0 point energy is 1 by 2 h nu.
Mm-hmm.
Okay.
Okay.
Okay, you can also write here, or we can say it's a ground state energy. Okay, so there is one more terms which you can write down, that via the value of something 1 by 2 h nu, or at the ground state energy level. So that we can write down here, that at ground state, some amount of energy also present. Okay, the next part. Okay, this is the energy level. Now let's suppose I have, I needs to vibrate any groups or any wave which is in this energy level. Let's suppose I have in this level. Okay, now I
Mm-hmm.
need some amount of energy to vibrate this bond. Okay, so how much amount of energy I needed in this case?
To vibrate that bond, it would be 3 by 2 and mu.
Yeah, 3 by 2 h new amount of energy needed.
Or
So
H
see,
nu, sorry, not
yeah,
N.
yeah, h new this is. So always we needs the amount of energy where the compound or where the bond lies. Okay, can I give it 1 by 2 h nu energy, and then the compound will start to vibrate? Is that possible?
Mm-hmm.
Hmm?
But if you no, I don't think so. Oh yeah, I think it can start it, yeah.
Yeah, great.
Mm-hmm.
Yes. So these are the terms which is 0 point energy or ground state. Okay. So now there is one questions, one question, that let's suppose I have aldehyde, and on another side I have ketone. Okay. So for aldehyde and ketone, we calculate 0 point energy for both
Mm-hmm.
of aldehyde and ketone. Now the value of 0 point energy in case of aldehyde and in case of ketone will be same or not?
What's H? Planck's constant, right?
Yeah.
H is Planck's constant, right?
Yes.
Okay, and then N is what? Vibrational quantum number?
Mm, what? The new? New is
No,
frequency.
mu. Yeah, mu is frequency. I'm saying N is vibrational quantum number, right?
Yes.
Okay. Uh, I think it dep vibrational quantum number. I think it depends. Wait, for what, aldehyde or ketone, right?
Yeah.
I think it w would be the same. Or
No.
actually, let me. No, actually, it wouldn't be
No, not
vibrational.
same. What is the reason?
Wait, the quantum number depends on the electronic configuration?
No,
Okay.
this value of this new value, the value of new. New
Oh,
is frequency here.
yeah,
Okay.
frequency is different.
Yeah, frequency. And frequency is related to
Wavelength.
wavelength. And wavelength is depends upon the energy of the radiation and the energy
Mm-hmm.
of a particular organic compound needed in any segment, anywhere that's present. Okay.
Mm-hmm.
So each and every functional group has a different ground state, so they
Mm-hmm.
will like shows different energy of that particular ground state. Okay, so you can also note
Mm-hmm.
down that part. Now you needs to note down each and everything in the IR. Okay, because all the things are interrelated. You can note down
Well,
with me.
what did you what did you say just now that I need to note down?
I'm writing here each and every
Um,
functional group has, each and every functional group has different group state energy, ground state energy, different ground state energy of vibration. So it will shows or gives different IR spectrum. Okay. Now, see, whenever we are discussing about any sort of spectroscopy, any type of spectroscopy, okay. So in that part, we need one terms or one rule we can say, that is selection rule. Okay. So in each spectroscopy, it can be IR, it can be NMR, it can be microwave, X-ray, gamma ray, so each spectroscopy has their own selection rule. Okay.
okay.
So you can write down here the first selection. What is the selection rule for IR spectroscopy? Hmm, Selection rule. So there is two selection rule. Okay, so in that case, the first selection rule is the amount of energy needed. Okay, amount of energy needed, or we can say frequency needed, that is nu1 is equals to nu2. Nu1, let's suppose the frequency for the organic compound which is present in the energy level, and nu2 is the amount of energy which is applying by IR, or we can say this is for organic compound, and this nu2 is related to the IR, or via we are getting via IR machine. Okay, so both the values of nu1 and nu2 needed to be same. So if the values are not same, then the compound will not start to vibrate. Okay,
But if
then
the
the
what?
second is,
Sorry, can you say that again? Sorry, like
what is nu1 and nu2?
Sorry, I was like copying this down. I don't know if I fully got every point. Okay, mu1 is the first frequency, mu2 is the second frequency, right?
Yes. So first frequency is for the organic compound.
Okay.
Okay. Let's suppose I have different energy levels. Okay. And here is my organic compound lies. Okay. And this organic compound is in a like this. Okay.
Mm-hmm.
This is in terms of wave we are talking about. Okay. So let's suppose the energy for this one is nu1. Okay, for organic compound. Now I need to start that I need that the organic compound start to vibrate. So what I'll do, I'll give it a IR radiation. Yes or no?
Mm-hmm.
This IR radiation generate vibration in this organic compound. Okay, so this IR radiation have a vibration frequency or nu, that's value is nu 2. Okay, so nu 2 wavelength or frequency is for the IR machine, and nu 1 is for organic compound. Okay, now this organic compound starts to vibrate when the value of nu 1 and nu 2 is same. Do you understand?
Yeah.
Okay. So wherever the value of nu 1 and nu 2 will be same, the compound will start to vibrate, or we can say coupling of these two waves will be take place. Okay. We can also write this term coupling of waves. Okay. Then
Okay.
after this second selection rule is that the organic compound must have a dipole moment. Okay, so organic compound needs to be have a dipole moment. Do you know how to calculate dipole, how the compound is a dipole or non-dipole? Do you know?
The dipole moment is when there's a significant charge difference between one region of a molecule versus another.
Great, great. So let's suppose if I am having HCl, so is HCl is
Mm.
a dipole or not?
HCl, yeah, because of the very opposite charges that repel.
And NH3,
NH3, yeah.
NH3 and PCl5.
CO5. Phosphorus has a does phosphorus have a positive charge? I'm like, I don't remember.
No, phosphorus is
No, it
having five
doesn't.
chlorine bond.
But as an ion, like if it were to work as an ion, no,
Yeah,
right? It's not positive. So that it wouldn't have a dipole then,
PCl5
right?
have dipole moment.
Oh, but you just said that PCl5 is not positive, but chlorine is negative, right?
Yes. Okay. So, like, are you thinking about the positive and negative charge? No, you don't need to think like a positive charge or negative charge. You only needs to check that that the atoms which are bonded to each other is same or
Mhm.
not. Okay, let's suppose if there is H2, so there is a bond in between hydrogen and hydrogen.
Mhm.
Okay, so when a bond in between hydrogen and hydrogen, in that case, this compound is not a dipole moment. Okay, because
No.
both of them are hydrogen. While we know that hydrogen is having positive charge, but in that case, we doesn't need to check charge. We check that the atom attached with each other is different or not. Okay. Then after that, secondary part is the charge. Okay. So let's suppose if I'm having CO2. Tell me, CO2 is dipole, like CO2 having dipole or not?
Yeah.
Having? How?
Yes, yes.
Okay, I'm drawing a structure of CO2 over here. Is the CO2 is like a dipolar atom or dipolar molecule or non-polar?
It's not non-polar. I don't think it's ionic. I think it's just polar.
See, this is delta positive charge due to this oxygen, and this oxygen is delta negative. Okay, so via these bond, this is dipole. So what? we represent the dipole moment or a polar molecule like this. Okay, this arrow. Do you know about this one? About the arrow?
Mm-hmm. Mm-hmm.
Okay.
Yeah.
So the head of the arrow shows the negative part of a compound, or tail shows positive part. Okay, so this is the first part. Then via this oxygen, delta negative and delta positive. Now in this case also the arrow is like this. Okay, so the dipole moment present but in opposite direction. So due to the opposite direction of dipole moment, the overall dipole will be zero.
Oh yeah,
Okay,
the total dipole.
yeah, so this is a
I think I was
non-polar moment.
I think I was only considering like I wasn't considering the whole thing, maybe like how each thing adds up.
Mhm. Okay, so now you tell me for H2O.
Oh wait, sorry, I just want to copy this down. Okay. What is that mu? Not mu, is that some another letter in Greek?
Yes.
Not lambda. I don't know why I'm
No,
saying
no, no,
lambda.
lambda is different.
What is this then?
This, which one? This new? New is
Oh,
stand
this
for frequency.
oh mu, yeah, what we just went over, right? It's the same
Yeah.
like earlier. Okay.
Hmm.
Okay, so you want me to do the segment by myself?
Yeah. Hmm.
Okay. Hmm. Oh, wait. So I have a question. So for the first example, is it non-polar because the two arrows cancel out because they're in like opposite directions?
Yeah. In case of CO2,
Yeah,
yes. But in
that's how
case of
you.
H2O,
In case of
now see.
H2O,
Yeah.
yeah.
Is
Okay.
it cancelled out or not?
I don't think so because the arrows are going in the same direction.
Yes. See, delta negative,
Mhm.
and this is delta
Yeah.
positive. Then again delta negative, and then delta positive. Okay. So now the dipole moment is going like this, and in this case also like this. Okay. If they are in opposite direction, that in that case also they are like not cancel out, because see, they are not completely opposite.
Yeah.
They are having some bonding in
Yeah.
between them.
That's what I was thinking.
So this
Yeah.
is the
Because
point.
the first one, because like both of them, like you have oxygen is negative, hydrogen is positive, but like it's going in the same direction, right? Which is different from the first one. It's going in the opposite, but in a
Yes.
linear fashion. Like there's no angle. Like here, like there's an angle, right? Kind of up to oxygen.
Mm.
So it's
Yes.
not like it completely cancels out. There's some like, yeah. I definitely studied this in general chemistry a long time back,
Yes.
but
Yes. Okay.
I kind of
So this is
forgot.
about, no issue. This is a easier part. You can like
Yeah, it's easy. Okay.
okay, so in selection rule, there is two rules. The
Mhm.
first is the energy or the frequency of organic compound, and the IR needs to be same. Then in the second, that the compound must be having a dipole moment. So if a compound is having a dipole moment, then the compound is known as IR active.
Mm-hmm.
Okay, these are the two selection rules. Now we are starting the mode of vibration. Okay, mode of vibration means this is the next topic we can say. Mode of vibration represent like how many
Mm-hmm.
types
Mm-hmm.
uh, vibration can be take place in our organic compound. Okay, so let's start with modes of vibration. Mode of vibration. Okay, so in the first case, there is two type of mode of vibration. The first is stretching mode of vibration, and second is bending mode of vibration. Okay, stretching and
Mm-hmm.
bending. So you can write
Yeah.
down that there is two part. The first is stretching. First is stretching mode of vibration, and second is bending. You can note down with me, okay?
Okay.
Bending mode of vibration. I'm writing as MOV, that is mode of vibration, okay? You can write down the whole thing.
Yeah.
Okay. Then again, the stretching and bending is converting into two part, that is symmetric and asymmetric. Okay. Now, what is symmetric and what is bend asymmetric? So, firstly, mode of vibration, you can assume that there is a bond in between. There is two atoms which is having a single bond. Okay. Now we are calculating like how many types of vibration can show by this molecule. Okay. Let's suppose this is A
Mm-hmm.
and this is B, and how many types of vibration this can be shown. Okay. So firstly, we
Mm-hmm.
are discussing about stretching. In stretching, there is two, symmetric or asymmetric. Okay, symmetric and asymmetric. Let's suppose I am having one more, I can add one more part. This is B over here. This is a whole compound now. Okay, so now let's start with the symmetric part. So in case of symmetric, what how can symmetric vibration take place? So let's suppose this is B and this is A and this is B. So firstly, the bond is going inside like this. Okay, so this bond will be shorter, and in the another case the bond will going outside. But see, what is the meaning of symmetric? Symmetric means both bonds are behaving same, like one bond going outside, then the another bond will also going outside. Okay, symmetric
Mm-hmm.
means in the same direction, oh sorry, in the same way. So if the bond will going to larger in case of this, so this will going like this. Okay. Symmetric means linear movement. Okay. Or movement in the same way. That is symmetric. Now we are discussing about asymmetric. So let's suppose I have this bond, this compound. And now in case of symmetric, let's suppose this bond giving outside. So in that case, this will going inside. Okay. So this can be shown by this. Okay. Is it symmetric or asymmetric vibration? This is the first example.
Mm-hmm.
This is second. This is the third. Okay.
Still copying it down.
Okay.
It takes time, to copy it down.
Yes, yes, yes. It needs time. And you
Yeah.
also needs to time to digest these things because I think
Yeah.
all these part is new for you. So you can take your time.
Yeah. It's very new. Yeah.
Yes.
Like the stuff that we went over before this like class started, or
Hmm.
like in the beginning,
Hmm.
uh I think it was like all stuff that I pretty much knew from organic chemistry part one that was just kind of
Yes,
like
yes,
review.
yes. This is not organic
Yeah.
chemistry. Seriously, this
It's
is
not?
used for, yeah, this is used for in master's level for any like a sort of research and all of that part.
Oh, really?
These are
Because
machinery parts. Yeah.
in America, like this basically constitutes organic chemistry part two and like a bachelor's degree.
Okay, so you are pursuing
Yeah.
bachelor's degree. So in our
Yeah,
case,
I'm not a master's student at all. I'm like a bachelor's student. Yeah.
okay. So in our syllabus, the
Mm-hmm.
spectroscopy is a whole new subject, a complete new
Oh,
part. Yeah. So yes,
oh,
we needed spectroscopy when we are doing our research.
yeah.
Yes, we needed spectroscopy, but spectroscopy is like doesn't have the concepts which
Mhm.
we are dealing with chemistry. It is a whole new subject. So you need a lot of time for sure.
Yeah,
Okay,
yeah. I mean, yeah,
you can ask me anything wherever you are having any sort of doubt or any
yeah,
doubts. Okay.
yeah. Definitely in like the next session, if I really feel like I didn't understand, I have doubts, I'll bring it for sure. Yeah.
Sure, sure.
This is very new of a concept.
Yes.
Like when I opened the textbook, I was like, this is 50 pages. Like, how is this 50 pages?
I
Okay.
don't think so that you need to go with that textbook for now because
Okay.
because that is a little bit
Yeah.
complicated. The whole part is in theoretical part. So I
Yeah.
don't think that is helpful for now. After completing this chapter, you can go with that.
Okay.
Noted.
Okay. Yeah.
Okay, great. Then, do you understand now what is symmetric and what is asymmetric?
Mm, it's like the stretching is in the same direction, or not the same. It can be same or opposite, but the same amount of stretching, right?
Yes, same amount of stretching, that is symmetric. But different
Mm-hmm.
amount of stretching, that is asymmetric.
Asymmetric. Yeah.
Okay. Then now in case of bending, bending is bending again, two types. So the first is in plane bending, in plane, or another is out of the plane. Bending is a little bit tougher part.
Mm-hmm.
In plane bending, or you can write down here, out of plane bending, out of plane bending. Okay, so now in plane bending, then in case of in plane bending, there again it's converting into two part. The first is scissoring and the another is rocking. I think you will like when you discuss or you studied the textbook, in that part there is some term like scissoring and rocking will come, so you need to
Yeah,
know
yeah.
what. Yeah, scissoring
The
and rocking.
professor also mentioned in his lecture too, like even in class he mentioned scissoring and rocking.
Hmm.
Yeah. But
Yes.
obviously like I didn't know because I was like a new I was just sitting in the class so I had no idea like what these terms were, but yeah.
Yes. So that's why, like, yes,
Hmm.
we need firstly concept, then we can do it, that part. Okay. So let's again twisting and wagging.
Bending.
Now I
No,
think
Wendy,
these
wagging.
wagging. Okay.
Wagging.
Now these parts I think similar to you. What is scissoring? How scissor work?
You kind of cut in a certain way.
Yeah. Let's suppose if I'm having A,
Mm-hmm.
B, and B. So in case of scissoring,
Mm-hmm.
both B are work in the same part, yes or no? Like this,
Mm-hmm.
first they will come closer and in the another part they'll go.
Mm-hmm.
That's how scissor work. So that part is known as scissoring. But see, both the B and B atoms work in a plane motion, yes or no? In a plane.
Mm, I don't know. I think so. Yeah.
Yeah, they are in the plane, like all the atoms are in the
Mm-hmm.
same plane.
Yeah.
Yes, so that is
Oh,
scissoring.
B. Are you talking about B? Like, are you talking about B?
Yes, I'm talking about B.
Yeah, they're in the same plane.
Yeah. Okay.
Okay.
So in case of scissor, do you understand scissoring by the scissor, like how scissor work? So as scissor, that compound is
Mm-hmm.
also vibrate. Okay. First they open up and after that they close up. That's how they vibrate. in the plane, in the plane mode. Okay. Then rocking. Rocking is also in the plane, but see what is the difference in between rocking. So let's suppose again I'm taking this compound. But see, in case of scissoring, the B molecules, when one B molecules going inside, then another is also going inside. But in case of rocking, if one is going inside, the another is going outside. So can I say that if scissoring is work as symmetric, then rocking is behave as asymmetric?
Mm-hmm.
Hmm? So this is a type of symmetric we can say, and this is a asymmetric.
Yeah.
Okay. Then again, out of the plane. Out of the plane means twisting and wagging again. Wait a second, I am taking a picture. Then I think that is more clear to you. You can write down these part.
Mm-hmm.
Is that a picture clear to you or not?
Can you just enlarge it? And bring it to more of the center. Can you enlarge it a bit more? A little bit. Yeah, that's good. That's good. Okay. Symmetrical, asymmetrical. So like asymmetrical could be it's being moved.
Like, like firstly, the molecular vibration. Molecular is converting
Mhm.
into two. Okay. So stretching and bending. Yes, yes. So first is stretching and bending. Okay. Stretching is again converting into symmetrical and asymmetrical. As we discussed in case of symmetrical, both of them are go in the same direction, and in case of asymmetrical, in opposite direction. Then we talk about bending. So in case of bending, we discuss in plane. So there is two parts, scissoring and rocking. But in case of out of plane, there is wagging and twisting. So wagging is similar to the scissoring, but this is out of the plane. You can write down here. Same as scissoring, but out of the plane. Twisting again, same as rocking, but out of the plane. Do you understand? You can imaginate these structure after this class, okay? Each and every structure, and then think about like how they will work, okay?
Wait, sorry, can you go down? Sorry, because I want to copy this down,
Okay, okay.
this like particular image, because I can't really
Mm.
like. get
Mhm.
notes from you after. So,
Yes, yes.
okay, wait, let me just write. I think I do get like the difference between all of these different what's it called? Movement, yes, you'd say. Or stretching, sorry, stretching or
Vibration.
bending. Yeah,
Mhm.
so for stretching, right? Asymmetrical is just in a different direction as opposed to symmetrical, and also symmetrical, it's the same distance that you're stretching on both
Yes,
sides, right?
yes.
And then for bending, like scissoring and rocking kind of go like kind of back and forth in one direction, and wagging and twisting go like around the molecule, right?
Like we can say wagging and twisting is in the 3D manner.
Yeah, 3D manner.
Yes.
But like stretching is just like a very basic thing.
Hmm?
Stretching is like very basic in how it works, right? It's just
Yes, yes, yes. Stretching
Mhm.
is very basic, and bending in plane is also very basic.
Also wanted to ask, should I like leave all the logistical questions that I have like towards the end, like about my class and stuff and like the syllabus?
Yeah,
I
you
don't
can
know.
ask.
Or like, can I ask during the session? Because I don't want to like distract from like everything, if that
Oh,
makes
you can
sense.
ask me. You can ask me.
Okay.
Do you have any doubt up to now? Anything?
No, I don't think what I'm asking is like, like questions related to like my coursework or my course, like my syllabus or, things like that, if that makes sense. Like, should I leave those towards the end? Because I don't want to ask them in the middle and then I get distracted from like the what you're teaching me.
Hmm. Yeah, that part we will discuss at the end. Like if
At
we
the end,
start,
right?
yeah, if we are start discussing in between, then
Okay, yeah, sorry. Like I didn't mean to distract. I'll just
oh,
ask at the
no.
end.
Mhm. You can ask. Okay.
Yeah.
Can we start further? Like one more topic. After that, we will discuss your.
No, no, no. I'm not in a rush. I just don't want to like, like I don't want to distract, but I also need to ask you about certain things like with my course and stuff, like how we should proceed, I
Okay,
guess.
okay, you can ask me
Yeah.
now.
Like, so I remember you told me like the textbook isn't as important, but one of the I think assignments
Yeah,
the
yes,
professor gives
yeah.
is
Hmm.
oh, you already know. Okay. Chapter
Yes, yes,
summaries.
yes, yes. I know.
Okay. But for this chapter, when I asked my classmate, she said it's not like she's not gonna, it's not mandatory or anything. So I don't have to make a summary out of it. So I think starting from, I don't know if it was NMR spectroscopy, which we started this week. For the next chapter, I think he's gonna require some sort of a summary off the textbook. I don't know. But right now, we don't need to worry about that. I
Okay, in
think it's
case of
not that important. I think that was all. Yeah, that's all I really wanted to say. I don't think there's anything else.
okay, okay.
Yeah.
So for IIU doesn't need, but for NMI you need yeah, like a summary of. But I will share summary part. If you need it anytime, I'll share summary part. Like you can tell me a day before, like whenever you need to
Oh
submit.
my God, thank you.
Yeah. So you don't need to worry about that.
Oh my God. Okay, thank you. That would be really helpful. It's every Sunday, I believe it's due for us. Like we have to submit a summary or something.
Every Sunday. Okay.
Every Sunday, yeah. Every
Okay.
Monday we begin another chapter. So this week it was like NMR spectroscopy. Last week it was like IR spectroscopy.
Okay. Okay. Okay.
Yeah, I don't, does that make sense like to you or
Yeah,
do you
yeah.
want me to explain
So,
anything? Okay.
yeah, so like it's helpful for me. Like I share the part of summary with you. Okay, a PDF part.
Okay.
So you
That would be
can.
very helpful. Thank you so much. Yeah, I really benefit from that.
Mhm.
Okay, yeah, sorry, you can continue to the next topic, ma'am. I don't want to like, yeah,
Yeah, yeah.
st
Okay.
hinder you. Wait, sir,
Mhm.
where does it, for twisting, what did you say? Same as rocking, but what was but in plane?
Out of the plane, but they
Oh,
are
oh,
out of
oh.
the plane. What is the major difference in between twisting and scissoring? That scissoring is in the plane and twisting is out of the plane part.
Okay.
Okay. Okay, so now we move. Okay, so why we need this part to discuss? Like, is this helpful for us to read out the spectra or anything? And what is,
Why are we using? Sorry, go
yeah.
ahead.
Mm-hmm.
Oh,
Tell me.
my answer was gonna be like based on the graph, it kind of shows us what like how to explain it, like the vibration of the molecule, but it's like
Yes.
you can't see that through the naked eye, so you have to like represent it through a graph, right? Through data that you collect through a spectrometer, and that's just I guess
Mhm.
the science of using the spectrometer. I don't know.
Yes,
And
yes,
that's how it
yes.
shows up on the graph, like the it indicates something, I
Yes.
guess.
Indicates some sort of peaks in the graph.
Yeah,
Okay.
exactly. Yeah.
So, yes, in case of IR, we are getting a lot of complex spectra as compared to NMR and microwave and any other
Mm-hmm.
spectroscopy. Okay.
Yeah.
In any other spectroscopy, like the graph is in the simpler side. Okay, but in case of IR spectroscopy, we are getting a little bit more complex part or a complex graph. Okay, so the question is, why in IR spectroscopy we are getting a this much complex graph? So the answer for that is due to a lot of vibration, a lot of stretching, bending, symmetric, asymmetric, in plane, out of plane. All of that of vibration can create different peaks. So let's suppose there is symmetric vibration will be take place. So in that case, one peak for symmetric, one for asymmetric. So that's how there is a lot of peaks in a graph. Okay. So that's why we are getting complex spectra in case of IR. That's the reason which
Mhm.
that's we are discussing over there. Okay.
But like
Then-
the peaks
Mhm.
need designation because there could be various different types, right, depending on what's going on.
Yes, yes, yes.
Mhm.
Okay. So after that, you need one more, we can say, now we are starts to discussing spectra, like how what type of spectra we are getting, what how the spectra is complex or why not it's complex, and what sort of vibrations in a particular spectra. Okay, so that's how there is two or three more terms, that is fundamental, overtone, second overtone, hot band, and all of that. Okay, so let's suppose if I have the value of n. This is showing the value of n. Do you know what is n?
No, not frequency. I'm sorry. What was it? Vibrational note. But yeah.
Vibrational quantum number. Do you remember that energy levels which we are discussing?
Yeah.
Yes. So whenever any organic compound gain energy and go from 0 to 1 energy level, okay. So in
Hmm.
that case, we are getting a fundamental band. That band is known as fundamental band. Fundamental band. Okay. If we are going from 0 to 2 energy level, then that band is known as overtone. Okay, overtone, or we can say first overtone. Okay, when we go from 0 to 3rd, then this is known as again overtone, but it is second overtone. Okay, then there is one more, that if the organic compound going from first vibrational quantum number to the second quantum number, then that is known as hot band. Okay, these are
Hmm.
some terms only, these are only some terms which you needs to know before studying any graph. Okay, so if examiner asks you when we are getting fundamental bends, so let's suppose if I'm again generating that energy level, so here is n is equals to 0, n is equals to 1, here is n is equals to 2, n is equals to 3. Okay, now I'm generating some overtones or some bends. Now you tell me if this is the first transition, so in that case what sort of bends we are getting when n is equal to 0 to 1. Hmm. Hmm. Hmm.
Uh, No. Sorry. 0 to 1, right? Fundamental.
Yeah.
Oh, did you want to? Sorry, did you want me to answer the second one, or
Mhm.
you wanted me to like answer this 1 to 2, or like n equals 1 to n equals 2? Did you want me to answer like what it would be, or?
I just want to ask you that when I have energy level
Mm-hmm.
from 0 to 1. So in that case, what sort of band I'm getting? Via check here.
0 to 1 is fundamental.
Yeah. And if I go from first to second, then
Hot band.
and from 0 to 4, let's suppose is 4.
Mm-hmm. 0 to 4. I
Mhm.
don't think you wrote that here. Third overtone?
Yeah.
No. Yeah, third
Yes, yes.
overtone.
Third over. Okay. Okay, so that's how we identify
Mm-hmm.
different bands, and then one more terms you can write down for hot band. For hot band, that hot band always obtained at a higher temperature. Obtained at higher temperature. Okay. These
Okay.
are some terms which we needs to which we needs to learn before next class. Okay. From next class we started to
Mm-hmm.
discussing about spectra, about each graph. Okay, so these are terms which you needs to know and you needs to learn before next class. Okay, then you can write down one more thing, that is
Mm-hmm.
energy.
Mm-hmm.
Okay, so the value of nu in case of stretching is greater than the value of nu in case of bending. This is the next part which you need. Like stretching needs a lot of more energy as compared to bending.
Mm-hmm.
Okay. Then there's Fermi resonance.
That's all. Or
Mm, yeah,
because
that's
it's
all.
already a lot, right? It's all new stuff for me.
Yeah,
New
yes,
topic.
yes. From next class, we will start some data. Okay. If
Okay.
okay, so for now, I don't think so. You need homework because there's a lot of stuff.
Just like revise, I guess, everything. I don't know.
Yeah, yes, yes,
Okay.
yes.
Because I
Okay.
don't even understand I don't even know the concept very well, so I think I need to understand that first. Like what
Mhm.
is going on, what's the concept or how a spectroscopy works. Um,
Mhm.
I mean it's like a tool, right? You're just like looking at different
Yes, yes. It is a
quantum
machine.
nodes. It's a machine.
Yeah.
And the quantum nodes, from what I understand, like the quantum nodes are basically helping you identify like what's going on. The
Mhm.
bands. So these
Yeah.
bands indicate something.
Yes, the bands are like a spectra in spectra.
Oh, wait,
In
let me write
spectra,
that down.
different in the spectra we are getting different peaks. So that peaks are
Hmm.
known as
Wait, so the band, sorry, can you say the band is the spectra or peak in spectra, right?
yeah,
Peak in spectra. Oh, so these bands determine the peak. Okay.
yeah.
Not. not the spectra themselves.
Yes.
So then what's the spectra? Just like the sample that we're looking at, or
Spectra is the graph.
oh, spectra is the graph. Okay.
The graph is known as spectra, but whenever we are just like as
Mm-hmm.
the graph we are getting from a machine and it's related to the organic compound, so in that case it's known as spectra.
Oh, okay. Yeah, I was just writing this down because I don't know all the terms, I just want to be clear.
Mhm.
Um, so I'm just gonna like try to see if I have any questions, like if I can summarize what we talked about very briefly, like the
Mhm.
what's it called? Where so you gave me an equation E equals n plus one half and then nv, right? So and then mu is the or sorry, not v, mu. The mu is the frequency, and then you have Planck's constant, then you have vibrational quantum number, and then each node has quantum node has a certain uh like ratio of the energy, I guess, like depending on what level it is.
What?
Yeah.
Vibrational quantum
Like
number.
the no, sorry, like the energy level, right? So
It's
how like how you have at n equals zero, like that's the node, right? N
and
equals
it,
zero.
that's
That's
what I
no,
like.
that's a like the n, right? N, does that represent oh vibrational quantum number?
Yes.
Okay, number. So like at each number, I thought it was a node. I don't know if that's the same thing. I no, I don't think so. Uh,
Yes. N is represent the vibrational quantum number.
okay, number. So each number has a specific formula or reiteration of the energy level of a vibration equation, basically, right?
Mhm.
Something
Mhm.
like n equals zero would be one half
Half
h
H.
mu.
Yes. Yes, n
Yeah.
is equals to 0, that is vibrational quantum number. And for that vibrational quantum, E is equals to 1 by 2 h nu is the energy.
Mm-hmm.
Yeah.
Oh, okay.
Mm.
This whole thing is the energy, right?
Yes.
This whole thing is the energy. Okay, let me write that. And the 0 point energy is basically n equals zero, right? Ground state energy.
Yes. Ground state energy. Yes.
Okay, and then we talked about functional groups. So if you want to determine the differences between different functional groups, there's like a certain rule, right? Selection rule. And then each functional group has a different ground state.
Mhm.
So you're gonna get different spectra. And then you talked about selection rule, and then it has to do with like polarity and then coupling of waves, right?
Yes.
Though so coupling of waves means coupling of the frequency, right?
Yes. Coupling of waves means coupling of frequency, or we can say the amount of energy needed to vibrate any compound.
Okay,
Okay, because
amount.
frequency is directly proportional to energy.
Yeah,
Yes.
but what is that the selection? That's all the selection rule is, right?
Yes. Yes.
Okay. And then we talked about modes of vibration, which I have to go study, but like I have the basic idea of that, and I think that's all. And then we talked about the bands. So I think this is like all of my that's basically like my homework is to review up everything, right?
Yes.
Okay. And then as for like the logistical updates, I guess, about my class, I'm not really 100% sure because I'm still not enrolled yet, but I know some people have dropped the class, so hopefully I can get a seat or something. And then once I get in, I think I'll be able to like give you more updated information. So yeah, I
Yeah.
apologize for that. I feel like I'm giving you very like vague information, like it's not update. I don't know. It's like not very updated, I guess. But
Um,
yeah.
Not really, because that's enough, I think, because for now you are not a regular student.
Yeah.
So
That's the issue. Like that's the main difficulty here.
yes.
So I can't, it's hard to give you like very like updated, like
Mhm.
information. But I think when I interacted with a classmate, she said like, like last week they had organic reactions review the worksheet was due,
Mhm.
and then this week the IR worksheet will be due. So I think like we'll have time to work on the IR worksheet
Mhm.
this week. Yeah.
Yeah, we'll do that.
But other than that, I feel like I'm in the dark too. I'm kind of clueless, so I feel like I'm not really able to like really give you
No,
the give you enough, I don't know, clarity or something.
not really. Seriously, I think it's not that much complicated as you assume. You are
Okay.
assuming a little bit more complicated each things. Like you can do everything. That's not hard part. And
Mm-hmm.
if you if you are regular in at least in this class, so in that case you are like having some concept.
Mm-hmm.
Maybe you needs to prepare for exams. Okay, you doesn't need to stress about like how to going on in colleges, what's the thing, what is all the thing is happening over there because I met here. You doesn't need to think about that.
Okay.
And you
Yeah.
need you only need your degree, your mark sheets, and all of that stuff. Okay, you doesn't need to stress about these small things. I think so.
Sorry, I'm like I overthink a lot. That's
Yeah,
probably
you
why.
are just like, yes, your complicated things are a lot, as I'm assuming. Okay, you doesn't need to stress about these little things.
Hmm. Yeah, and also the professor said like if you do get enrolled, like anything that I've missed, like he would extend time for me to like do them. So I think I'll be
Yeah,
fine.
that's great. So
Yeah,
why stress about these things? Because a professor
yeah,
also knows that you are not a regular student over there, so they'll also help you. Okay.
yeah,
Hmm.
yeah. I couldn't go to class today, but I'm hoping maybe on today's Wednesday here, Wednesday night. Maybe next week I'll go. I couldn't
Okay.
go today. Yeah.
Hmm.
But it was nice having a session. I think I am overthinking way too much.
Yes.
Thank you. Thank you, and have a good rest of your day.
Okay.
Bye
Bye.
bye.